This is the second video for 5.5. We may have to do factoring. Notice that these ones are again asking for answers between 0 and 2 pi. On number 4a, think of the cosine as being like an x. So if I had given you 2x squared minus 7x plus 3 back in an algebra class, or early on in this class, we would have factored this. Same logic, except instead of it being x, it's cosine. So this is going to factor like a quadratic factors. I'm going to have 2 cosine, because if I multiply those, that would give me 2 cosine squared. Then you can do a guess and check or a X box method, however you want to do it. Remember, you're going to have to multiply the 3 in the end. And what works is 2 cosine minus 1, cosine minus 3. If you check that with FOIL, it does work. Now, remember what you used to do if that was an x. If I had 2x minus 1, you would tell me that x equals a half. Same logic. Except it's not that x equals a half, it's that cosine equals a half. And on the other factor, cosine would equal 3. So that's the algebra part of this. Now we get into the trig. For the red equation, where does cosine equal positive a half? Well, cosine is a half at a 60-degree reference. Cosine's positive in the first quadrant and in the fourth. And so those two angles are pi over 3 and 5 pi over 3. Now for the blue equation, cosine can't equal 3. The biggest cosine can be is 1. So this cosine equals 3 doesn't produce any solutions. So the only solutions that happen are pi over 3 and 5 pi over 3. And again, I'm not saying plus 2n pi because it only wants solutions in the basically first spin around the unit circle. For letter B, this one's actually a slightly easier factoring problem. I basically have 2 terms here. I have tangent sine, negative 4 tangent. They have a GCF of tangent. So I can factor out a tangent. From the yellow stuff, that would leave me with sine. From the green stuff, that would leave me with minus 4. Since it equals 0, this means if tangent equals 0, we're good. Or if sine equals 4, we're good. So let's look at the tangent equals 0. Where does that happen around the unit circle? That happens when the sine is 0, because tangent, remember tangent is sine over cosine. If the top is 0, we're good. That happens at 0 radians, because you'd have 0 over 1. So 0 radians is an answer. Tangent is also 0 over at pi radians. Its coordinates are negative 1, 0. So the answers to tangent equals 0 happens at 0 radians and pi radians. Where does sine equal 4? Similar to the last problem, sine cannot pass 1. So there's no solutions to that part. So 0 and pi are my only answers. For a few more factoring problems on the back. Number 6 is another one of these that look an awful lot like factoring a quadratic. So I'm going to think of it like I'm factoring a quadratic. And again, you can guess and check. You can factor by grouping. You can X box. Again, think of it as if you're factoring 6x squared plus 11x plus 4. Except being an x, it's sine x. The factors are actually going to be 3 sine x plus 4 and 2 sine x minus 1. So for the first factor, if sine is negative 4/3, we're good. For the second factor, if sine is 1/2, we're good. Looking at the blue one, sine is negative 4/3. No, it's not. The lowest sine can reach is -1. Negative 4/3 is too small. So, oops, there we go. So that does not work. That doesn't produce any solutions. Where does sine equal 1/2? We've already done this. It's a 30 degree in the first quadrant, pi over 6. Oh, I'm sorry. I made a mistake here. Sorry, this, when it factored, was 2 sine plus 1. Sorry about that. Which would mean this is -1/2. Which means 7 pi over 6, which we have done this as well. 7 pi over 6 and 11 pi over 6 are my answers. On letter D, I see that I have cotangent squared on both sides. It might be tempting to say, oh, let's just divide out cotangent squared. I don't want to do that because if cotangent squared is 0, then I'm dividing by 0. So I don't want to divide anything out when I'm doing this with trig functions. But what I can do is subtract this over. So this is going to be minus cotangent squared cosine equals 0. So I can subtract it, and instead of dividing cotangent squared, I factor it out. So I have two terms. They have a common cotangent squared. So if I factor that out, that would leave me with 1 minus cosine and so if cotangent squared equals 0, we're covered. Or if cosine equals 1, we're covered. So with the cotangent squared, don't get hung up on the squared. If something squared is 0, that would mean the same thing as if just cotangent is 0. So really think of this as when cotangent is 0. Cotangent is 0. Well, remember, cotangent is cosine over sine. So now we need to know when the cosine is 0. That happens at pi over 2 and at 3 pi over 2, because the x-coordinate is 0 at those. So cotangent is 0, meaning cotangent squared is 0, at pi over 2 and 3 pi over 2. Again, that's pi over 2 and 3 pi over 2. For the blue one, when is cosine equal to 1? That happens only when the angle is 0. That's when cosine equals 1, so that would be 0 radians. So there's your answers on that one. The last type we're going to look at is where maybe we throw in some identities. Now notice that these again say interval 0 to 2 pi, so I'm not going to be saying that plus 2n pi. So on 5a, there's nothing that I can factor out of both of these. They don't have a GCF or anything. Since it's cosine and sine, I can't think of it like a quadratic. It's like having an x and a y in there. But I can replace cosine squared using a Pythagorean identity. Remember that sine squared plus cosine squared is 1, Cosine squared then is 1 minus sine squared. So I can replace cosine squared with 1 minus sine squared. So now it's like I have just one variable in the problem, but that variable is sine. So if I distribute the 2, I'm going to have 1 plus sine equals 2 minus 2 sine squared. I'm going to move everything over to the left side, which is going to give me 2 sine squared plus sine minus 1 is 0. Now it looks like a quadratic that I can factor. This would factor into 2 sine minus 1, sine plus 1. So now it's similar to the previous grouping of problems that we did. If sine equals 1/2, we're covered. Or if sine equals -1, we're covered. So sine equals 1/2 at pi over 6 and 5 pi over 6. Sine equals -1, that's straight down at 3 pi over 2. I will stop this video here and we'll do one more video for the last 3 problems.